Common Core 9th-12th Standard N.RN.1. First, let's look at an example. Let's simplify the square root of 200 by removing the perfect square factor. Well, square root of 200, what does that mean? Well, we want to rewrite that radicand as the product of the perfect square factor and the remaining factors. Well, what is that? Well, perfect squares are numbers like 4, 9, 16, 25, so on and so forth. And the radicand, well, that is the number inside of the square root. So we want to rewrite 200 as some number that's a perfect square times anything that's left over. So here's what I would do. I would think about all the perfect squares and I'd go, okay, what is the biggest perfect square that's less than 200, but it will go into 200? Well, what would that be? Well, in this case, it is 100 times 2. 100 times 2 is 200, but yet 100 is that perfect square factor. Now, why did we do that? Well, what we can do is, since these numbers are multiplied, we can look at them as square roots of each number. So square root of 100, well, that's 10. And square root of 2, well, it does not simplify. So that means that simplified, the square root of 200 is 10 square roots of 2. Now let's talk about another possibility with simplifying radicals. And that's when you have a variable inside of the radical. Well, they work a little bit different, but they are the same principle. Well, remember, anytime we're involving constants, we've got to remember those perfect squares to factor something out of that square root. Let's look at the problem, the square root of 75 x to the 5th. How do we simplify this? Well, the 75 is the constant, so we already have some idea how to do that. We look at the perfect squares and go, okay, which one of those perfect squares will go into 75? Well, of course, it's got to be less than 75, and if you look at the list, you'll notice, well, 25 times 3, that will give us our 75. But now, what do we do with that x to the 5th? Well, here's what we do. Anytime we're talking about square roots, which we are on this one, we want to go for the biggest exponent that is an even number, but is less than 5. Well, what would that be? Well, x to the 5th, what that means is it will break up into two different x terms. And the biggest even number that's less than 5 is 4. So it's going to break up into x to the 4th and x to the 1st. Because remember, if you have the same base, you can add exponents. So 4 plus 1 is 5. We are not changing the value. We are just changing what the value looks like. Now, why would we do this? Well, now that 25x to the 4th, I can do something with that. That 3x to the 1st is more or less my leftovers, because you cannot take the square root of 3, and you also cannot take a square root of an odd exponent, okay? So remember, we're only talking about square roots. We'll talk about cubes and all that later in the future. So how do I do something like this? Well, the square root of 25, we all know, hopefully, well, it's 5, okay? And you can use your calculator to help you if you need it. But that square root of x to the 4th, what do I do with that? Well, here's what you've got to realize is inside of a radical, there's actually an index. And in this case, I keep saying square root. Why? Well, because a square root is understood to be 2. In other words, you need 2 of something in order to factor something out. That's the reason square root of 25, well, that's 5 times 5, which is why the square root of 25 is 5. Well, the square root of x to the 4th, what is that? Well, again, x to the 4th, what two things just alike does it break up into? Well, 4 divided by 2, if I look at the exponent, is 2. So that means the 25 square root of 25 is 5, and the square root of x to the 4th is x squared. That's the two things just alike that x to the 4th breaks up into. And then the 3x is left over, so it's still inside of the radical. So the square root of 75x to the 5th simplified is 5x squared square root of 3x. Now sometimes you're also going to have to simplify fractions within radicals. So that means, like, if you have the square root of 25/9, how do you do that? Well, with a fraction, you look at the top as a square root and the bottom as a square root. So you do the square root of 25, find the answer for that, and then do the square root of 9, find the answer for that. Of course, 25 is in the numerator, so its answer will be in the numerator. 9 is in the denominator, so its answer will be in the denominator. So what is the square root of 25/9? Well, it is 5/3, because the square root of 25 is 5, the square root of 9 is 3. So let's look at another example, the square root of 13/4. Now some of you are already going, well, this one's a little bit different, because square root of 13, well, I can't do that, but the square root of 4 I can. Well, exactly. Do that, okay? Square root of 13, you can't take that square root, so we leave it as square root of 13. But the square root of 4, well, that is 2. So the answer to that one is square root of 13, all divided by 2. Now we've got to worry about those variables as well. So how do we do something like this? Well, square root of 75, that's one we just did a moment ago, and we learned that it is 5 square roots of 3. And the square root of 16x squared, well, the square root of 16 is 4, and the square root of x squared, what two things just alike does x squared break up into? Well, it's x. So the answer is 5 square roots of 3, all divided by 4x. Now let's talk about another possibility with fractions and radicals, and that is you can actually divide them. So what I mean by that is square root of 144 divided by 12. Now some of you are going, square root of 144, I know that's 12, so let's simplify it. But wait a second. Before we start dealing with the square root, the numbers inside can actually already be simplified. And 144 divided by 12, well, that is 12. And this makes the problem much easier because it's a much smaller number to deal with. So make sure that you simplify first, and that's true of all math. If you can ever simplify, do it then. And 144 divided by 12, well, that definitely simplifies. It is 12. Well, now square root of 12, can I simplify that further? Well, yes, I can. What is a perfect square that 12 goes into? Well, it is 4 times 3, because square root of 4, well, that reduces to 2, and square root of 3, well, it's kind of a leftover, so I'll just bring it over. So the answer on that one is 2 times the square root of 3. Now let's look at another example, this time, of course, with variables. Now, how do I do something like this? There's an x in the numerator and the denominator. How do I simplify that? Well, anytime that happens, to simplify the exponents with the same base that are being divided, you subtract the exponent of the denominator from the exponent in the numerator. What do I mean by that? Well, x cubed, and it's divided by what's understood to be x to the first. Well, what you do is take the bigger exponent and subtract the smaller one, the one on the other side of the fraction bar. And 3 minus 1 in this case is x squared. But wait a second, the 12 and the 27 reduced as well, because what number goes into 12 and 27? Well, 3 does. 3 goes into 12 4 times, that's where the 4 came from, and 3 goes into 27 9 times. But we can still simplify this radical even further. So remember, anytime it's a fraction, you'd think of it as square root of the top divided by the square root of the bottom. So the square root of 4x squared is 2x, and the square root of 9 is 3. So that is our final answer on this one. It is 2x divided by 3. Now, on occasion, sometimes you just simply cannot get rid of the number in the denominator, and you can't take the square root of it. So what do? Well, there's a process called rationalizing the denominator that we have to worry about. How do we do that? Well, first of all, you may never leave a radical in the denominator. It's mathematically not correct. So anytime you have a radical in the denominator, we got to fix it. And to get a radical out of the denominator, you multiply the numerator and the denominator by the same radical expression. Some of you are going, yeah, I don't quite get what you're saying. Well, let's do an example. Let's look at 3 divided by the square root of 2. And we want to simplify this. Well, what's our problem? Well, we have a square root of 2 in the denominator, and we cannot leave a square root, a radical, in the denominator. So how do I fix it? Well, what I'm going to do is multiply the top and bottom by the same square root. And square root of 2, I'm going to multiply top and bottom by square root of 2. So that's how you do it. That's what I was talking about whenever I said multiply the numerator and the denominator by the same radical. Well, how does this help us? Well, 3 times the square root of 2 is just 3 square roots of 2. And radicals, anytime you multiply the same square roots together, like in this case, square root of 2 times square root of 2, well, the square root simply disappears and the answer is 2. And some of you are going, now why is that? Well, think about it. You're multiplying the numbers inside the square root together. And 2 times 2 is 4. Well, square root of 4, that reduces, that is 2. That's where it comes from. So make sure anytime you multiply a radical, a square root, times another square root, and they're exactly the same number inside, the same radicand, well, it just simply makes the square root disappear. Okay, so that is the answer. 3 square roots of 2 divided by 2, that is mathematically correct because now there's no radical in the denominator. So make sure these two numbers are a simplified fraction, that 3 square roots of 2. We can't simplify it any further, so that is our final answer on this problem. Let's try a couple more problems with rationalizing the denominator. Let's look at square root of 5 all divided by the square root of 12x. Now, how do I do a problem like this? Well, first of all, I'll look at the 5, I'll look at the 12, I'll look at the x. Nothing will simplify. There is no number that will go into 5 and 12 and simplify them any further than they already are. And the x, well, it's the only variable I have, so it's kind of stuck. So what do? Well, I'm going to multiply the numerator and denominator by some number that gets rid of that square root around that 12x. Well, the 12, we've got to make it a perfect square. So what is a perfect square that's got to be bigger than 12 that I can multiply 12 by in order to get it? Well, in this case, that's going to be a 3. Because 3 times 12 will give you 36, and square root of 36, well, that's 6. So that is the best number to use to get a perfect square. And of course the x, well, there's only one of them, and to take the square root, I need 2 of them. So I multiply by another x. And notice, whatever I do to the denominator, I do the exact same thing to the numerator. So now all of these numbers are inside of square root, so we can multiply them, and you just multiply fractions straight across. So square root of 5 times square root of 3x, well, that's 15x. And in the denominator, well, we got a square root, and 12 times 3 is 36. X times x is x squared. But that now will simplify. Square root of 36 is 6, and square root of x squared is x. But in the numerator, that 15, well, we can't reduce it because it's not a perfect square, nor can I multiply a perfect square times some number and get 15. And the x, well, it's just kind of stuck because there's only one of them. So that is our final answer. That simplified, that square root of 5 divided by square root of 12x is square root of 15x, all divided by 6x. We got rid of that radical in the denominator. Let's look at one other example. Square root of 7x all divided by 10. Well, again, we have the same problem. Nothing will go into 7 and 10, and square root of 10, well, I can't take the square root of it. So how do I simplify this? Well, we multiply by what we need. And square root of 10, 10 times what will give me a perfect square? Well, it's 10 times 10. So you'll notice I multiply numerator and denominator by square root of 10. Well, again, fractions you multiply straight across. So 7 times 10, well, that's 70. Bring over the x. And square root of 10 times square root of 10, well, that's square root of 100, which is 10. But remember, we said anytime you multiply two radicals that have the exact same radicand, the same number underneath, well, you just get that number. And that's what we did on that one. So this is how you deal with radicals and fractions.